Herbicide-Resistant Weeds in Missouri, presented by University of Missouri Extension. Feeding an ever-increasing population on a limited acreage will require continuous gains in crop productivity. Yet many factors threaten crop yields, especially the continuing loss to troublesome weed species. Modern herbicides provide a cost-effective, safe, and reliable method of weed control. Farmers typically choose herbicides over time-consuming physical or cultural weed control practices, which are often less reliable and more expensive. As a result, in most agronomic, ornamental, and horticultural crop settings, herbicides dominate weed control practices. Without proper management, this situation can present risks because applications of the same herbicide or herbicides with the same mode of action across vast crop acreages has led and will likely continue to lead to the widespread selection of herbicide-resistant weed populations. Herbicide resistance is defined by the Weed Science Society of America as the inherited ability of a plant to survive and reproduce following exposure to a dose of herbicide normally lethal to the wild type. Herbicide-resistant weeds are weed populations that were previously controlled by a particular herbicide, but are no longer controlled by a normal rate of that herbicide any longer. Weeds typically become resistant to herbicides when the same herbicide or herbicides with the same mode of action are used repeatedly in the same location over time. Herbicide-resistant weeds aren't created. Herbicide-resistant weed biotypes are selected from within the natural population. When herbicides are used, susceptible weeds are controlled, leaving only the herbicide-resistant weeds which increase, produce seed, and reinfest the area. The phenomenon of herbicide resistance in weeds is not new. Although insecticide and fungicide resistance predates herbicide resistance by several decades, herbicide resistance in weeds was anticipated as a potential problem as early as the 1950s, but did not come to fruition until 1970. In 1970, a population of common groundsel was found to be resistant to the herbicides simazine and atrazine, after receiving either 1 or 2 annual applications of these herbicides for a period of 10 consecutive years. Since then, the number of herbicide-resistant weed biotypes has increased each year in the United States. Although all types of herbicide resistance in weeds is concerning, the selection of glyphosate-resistant weed biotypes that is currently occurring in U.S. corn, cotton, and soybean fields is having a tremendous impact on the sustainability of these production systems. For over 40 years, glyphosate, sold as Roundup and a variety of other trade names, has been a valuable herbicide to corn and soybean producers. It offers a broad spectrum of weed control and has no soil activity, allowing for flexible crop rotations. When glyphosate was first introduced in the mid-1970s, its application was limited primarily to burn-down weed control in no-till crop production systems prior to planting. Glyphosate was usually mixed with or followed by other herbicides, a practice that increased herbicide diversity. These practices probably helped to delay the selection of glyphosate-resistant weed biotypes. In 1996, the first Roundup-ready crops were introduced onto the marketplace. Soon after their introduction, farmers rapidly began to adopt this technology to the point that these hybrids now comprise the majority of the corn, cotton, and soybean marketplace. In several respects, glyphosate and Roundup-ready crops have simplified weed management in these production systems. The first weed characterized with resistance to glyphosate was horseweed, also called mare's tail by many farmers. Within a short period of time, glyphosate-resistant horseweed was found across a wide geography in the United States. Similarly, glyphosate-resistant waterhemp and Palmer amaranth, two weeds in the pigweed or amaranthus family, are now infesting millions of acres in the Midwestern and Southern United States respectively. Although the total number of glyphosate-resistant weed species is low, the number of resistant species is increasing at an alarming rate. This means there is still time to adopt good management practices, limit the selection of additional glyphosate-resistant weeds, and extend the benefits of glyphosate and the Roundup Ready crop technology. Kevin Bradley is an associate professor in the Division of Plant Sciences at the University of Missouri. He is also the state extension weed scientist in Missouri. For the last 8 years, the objective of his weed science research and extension program has been to develop strategies for the management of herbicide-resistant and specifically glyphosate-resistant weed biotypes in corn and soybean production systems.
One of the most important things for a grower or retailer to be able to identify is the initial stages of glyphosate resistance, or really for that matter, any herbicide resistant scenario. And in this particular field right here, we have a perfect example of what you will see occur with a resistant population. And in this case, we have both species of water hemp and giant ragweed. So this field was treated initially with a burn down application, as would be very typical in Missouri, of a glyphosate and a 2,4-D for burn down. All of these have been treated with a labeled, in fact even higher than labeled rate of glyphosate. And what you will find in a resistant population is some that have survived the treatment. Giant ragweed here that's got a chlorotic top, some burning around the leaf edges, but that plant is not going to die, and in fact that plant is resistant. All signs are showing us that. And right next to it we have another giant ragweed plant. You know, it's hard to tell it's a giant ragweed plant because it's completely dead, but it was controlled by that same application, and it's very likely that these plants were at about the same size at the time of the application. So one was killed, one was not. We have a mixed population out here. They are not all resistant yet, but the longer that we don't employ some management practice, the more we'll see the population become dominated by the resistant individuals. And the same thing with the water hemp. You see there's a sporadic water hemp here. They've really taken off, and really some of them look like they haven't been affected at all from that application 2.5 weeks ago. But some of them are dying or are already dead. You see some more of these corpses around through here, and those are in fact water hemp that died. So this is exactly how we see a resistance population develop. You see sporadic plants here and there that have lived and some that have died. So it's a very critical part of resistance management to realize that, yes, I have here in this field a resistance population starting, and we're kind of on the initial stages of identifying it, but it has been established for a number of years.
Historically, giant ragweed was found mostly in undisturbed areas, such as fence rows and drainage ditches, and occasionally on floodplain fields. However, in the past 2 decades, giant ragweed populations have dispersed into many fertile fields across the Corn Belt. In most of the Midwest, giant ragweed seedlings emerge in late March. They can be identified by their large, spoon-shaped cotyledons, which range from 3/8 to 5/8 inches wide and 1 to 1 3/4 inches long. The first true leaves have deep lobes, but later leaves have lobes characteristic of giant ragweed. Giant ragweed leaves generally have 3 distinct lobes, but can have as many as 5. Although mature, giant ragweed can grow to 17 feet tall. Its height often depends on competition with other plants. In a field setting, giant ragweed is often 1 to 5 feet taller than the crop with which it is competing. The early emergence and rapid growth rate of giant ragweed provides it an initial advantage over many other weeds and crops. By emerging before other weeds or crops, giant ragweed exploits the available nutrients, water, and light before the crop. As a result, this species typically dominates the community in which it's growing by existing in pure stands. Kevin Bradley studies herbicide resistance in this northeastern Missouri soybean field that has become infested with glyphosate-resistant giant ragweed.
This is what a lot of growers will do. They will choose to put a tank mix in with their glyphosate even after the soybeans have emerged and we haven't controlled the giant ragweed with the burn down, or maybe we got additional flushes. And so what we're doing in this trial, you might see some little ribbons down in here, and that's actually where we're tracking the survival of the population. All of these plants with a orange ribbon around them, they were treated with a labeled glyphosate rate plus a tank mix partner in soybeans. In this case it was Famicefin or Flexstar is one of the trade names of that particular chemical. If you're going to take that approach, we want you to do it when they're very small. And again, this is a glyphosate resistant population. Bottom line is we would much rather see a pre-plant burn down treatment on giant ragweed that is effective, something with residual control and that also controls what's there at the time of application, and then come back with a tank mix in crop if possible. And so this weed here is another one of our problematic weed. It's called horseweed. Some farmers call it mare's tail. Scientific name is Coniza canadensis. Very common weed. It grows, it can germinate in the late fall or the early spring and really become a problem throughout the soybean growing season if we don't get it controlled prior to planting. As far as glyphosate resistant species, this is probably the one that is infesting more acres than any other current species. It was our first one discovered in 1996, and we've seen it just spread and take off since that time. Now, unfortunately, in this case, where you got all this horseweed or mare's tail that didn't get controlled, we're probably not going to control it from this point on. And this is a glyphosate resistant mare's tail, and it's had several applications of glyphosate already. We didn't have a different mode of action in the tank, and so we didn't get control, and now you're going to live with that for the rest of the season. We often get this kind of branching and this type of bushy growth habit as a result of not killing it the first time, and so the plant kind of branches out from there, and we see that occurring in a number of these plants. You know, there's some tops, meristems here that were killed out or burned out, and then so we get this branching pattern. This is probably 3 or 4 weeks away from producing seed, and that is it's a unique plant in that the seed of this species is aerially dispersed, and so it is really lightweight, and they're basically attached to tufts of hair, and so when the seed heads come out and you have those tufts of hair, any wind whatsoever and it gets dispersed in the wind, and that is probably played a pretty good role in why we've seen horseweed spread, and particularly glyphosate resistant horseweed spread. And there's been some researchers in the eastern U.S. that have been able to catch horseweed seed up in the upper atmosphere layers. So this seed can really travel really long distances, and if it is resistant seed, then that's even more of a problem. So we could have avoided all this if we would have put a different mode of action in the tank with the glyphosate, 2,4-D for example, dicamba. Saflufenicil is a kind of a newer active ingredient that is sold as any of the kick sore products like Sharpen. Those are the trade names of some of them. And so we really need to manage this weed as prior to planting, before the soybeans ever emerge. Once the soybeans are up, our chances of success go down dramatically. Well, as you can see here, we have a great infestation of water hemp, and there's a lot of strengths to this weed. One of them is high seed production. And all of these plants have viable seed on them right now, or for the most part the female plants do. I just grabbed just a tip of one of the stems, and there's probably at least 50 to 100 viable water hemp seed in my hand right now. About 7 days after pollination, we have viable seed produced, and so pollination occurred probably something like a month or more ago. And that's really the problem with water hemp, is how much seed can be produced. And what happens when the combine goes through these plants, it becomes the perfect spreader of this seed. We couldn't do it any better if we tried. And so that's kind of what's happened with why we've got to this point. You've got a couple of things all meshing together to make it kind of the perfect storm. Each of these plants can produce anywhere from 300,000 to almost 1 million seed per plant. And so that's a big strength of water hemp. Another strength of water hemp is that it can germinate pretty much throughout the year. We can find some water hemp germinating right now here at soybean harvest. If it gets an opportunity, it can do so. It's kind of rare, but no problem for water hemp to germinate in July and August, and it is a continuous emerger. It's also a fairly fast growing weed. We've done some research that shows this plant in the height of the growing season, when we're trying to manage it, it's generally going to grow 1.5 inches per day. One of the things that we know as far as its weakness is it does not persist long in the soil. All of our recommendations for water hemp now center around this one fact, and that is that we want to prevent seed, water hemp seed, glyphosate resistant water hemp seed, from going back into that soil seed bank to be a problem in future years. If we attack it from that standpoint, we will be able to manage this weed much more efficiently than we have. In this four soybean row area here, we have 4 rows wide by about 30 feet long, where we've applied glyphosate at the labeled rate in 2 different applications on small water hemp plants earlier in the season. And here we are almost at harvest, and you can see that this is in fact a glyphosate resistant water hemp population. Those applications did no good, and now we're going to obviously have severe yield loss, and we have a lot of water hemp plants that survived and can produce seed and put on the soil. So this is kind of the comparison treatment. Here's a different treatment. Again, we have the same setup, 4 rows wide. I'm sitting in the exact middle of this particular plot, and you can see we have no water hemp. It's a clean treatment where we've managed this glyphosate resistant water hemp problem. So what's the difference? What's going on here? This was a conventional till situation, so we tilled, put on our pre-emergence herbicide, and then planted the soybeans. And after that, what's kind of the key and the new direction that we must be moving in for water hemp management in Missouri is not only a residual herbicide, but we came back when the water hemp broke through, and we applied a glyphosate, a mesofen, which is we call it a PPO inhibitor, and also a residual herbicide at that time as well. What I call that is overlapping residuals. So we put on a pre-emergence herbicide at planting. That is only going to last us a certain amount of time. When we come back with our post-emergence treatment, we put on a residual herbicide at that time as well, and that should get us through the season as it's done here. So we're overlapping that spectrum of residual herbicide activity, and we are going to have to rely on residual herbicides to manage this water hemp problem. We are quickly running out of post-emergence herbicide options for our pigweed problems in Missouri. So we've seen two examples so far. Here's a third example, and it represents another way that I feel we should be moving forward with our recommendations for water hemp management in Missouri specifically. This particular plot, again, 4 rows wide. I'm basically standing in the middle of the treatment where we have sprayed, 4 rows wide by about 30 feet long, and you can see it's very clean, no water hemp present at a site where we have tremendous populations of glyphosate-resistant water hemp. So what is different here is the concept of full rate of residual. That is another recommendation that we're moving forward with. Not only should we be applying a residual herbicide in our soybean production systems, but we need to think more about applying a full labeled rate of that product. For example, this is a treatment, the product name is called Authority First. One of the common ways that we have been applying Authority First is 3.2 ounces of product per acre. The label allows you to spray 6.4 ounces of Authority First per acre. This is sulfentrazone and chloranthalam are the 2 active ingredients in that product. And so you can see we have gotten excellent control because we've put on the full labeled rate of this herbicide. And in this case, we came back with a glyphosate and a famicefin Flexstar application, which is a PPO inhibiting herbicide, for those few escapes that were here. I doubt that we're ever going to have a year where we get complete control of all water hemp with a residual herbicide only. Sometimes you may get it, but it's a fairly risky scenario, so you're likely still going to have to come back with something post-emergence. You just want to, in this particular concept, you're putting more of your eggs up front in that basket in comparison to later in the season post-emergence. And we find that to be an effective way of managing this glyphosate-resistant water hemp problem. Again, this is a site where we have our glyphosate-resistant water hemp research. This is a different technology other than the Roundup Ready. This is LibertyLink soybeans. So you have a whole different new mode of action post-emergence for water hemp in this case. Glufosinate or Ignite you can use on glyphosate-resistant species. And as you can see here in this particular treatment, in between these 2 rows where we've treated, we've done well with this technology. What has occurred here is we put on a pre-emergence herbicide, which I would still recommend even in LibertyLink soybean production. But the catch is you have a post-emergence herbicide that is effective still to this point on glyphosate-resistant water hemp. And so we came in when the water hemp was about 3 inches or so in height after it had broken through those pre-emergence treatments, and we sprayed Ignite or glufosinate on small water hemp plants. And that's the key with this technology, is it can work. It is a different mechanism of action that's still effective on water hemp, but we must be treating small water hemp when we're treating. And again, I would still recommend a pre-emergence herbicide in this system. So this treatment has had a pre-emergence herbicide, and because of the season we've had, where we had multiple flushes of water hemp, we actually had 2 applications of Ignite here. Pretty much 100% of our yield that would have been here for us to get, and that's the goal. So our third recommendation moving forward with the glyphosate-resistant water hemp problem that we have in Missouri is for you to consider the use of LibertyLink soybeans and that technology. The way you're going to have to use that is still include a pre-emergence herbicide and timely applications of glyphosate on your weeds. But if you do those two things, you can make this technology work on your glyphosate-resistant weed problem.
Herbicide-resistant weeds are currently impacting agriculture on an unprecedented scale. Each year, herbicide-resistant weed populations occur with increasing frequency in response to the selection pressure imposed on them by modern crop production techniques. In order to prevent this situation from degrading further, producers must have a change in their mindset of weed management. For the most part, weed management decisions are currently based on single-year economic thresholds. However, in order to stop the spread and progression of herbicide-resistant weed populations, producers must think longer term and diversify their weed management techniques. This includes considering all available chemical, cultural, mechanical weed control methods, with the ultimate goal of eliminating weed seeds from the soil seed bank. Because many current herbicides have the same mechanisms of action, producers must understand herbicide mechanism of action and frequently rotate to herbicides that have different mechanisms of action so that resistant weeds do not predominate our production systems. Ultimately, the focus must shift from a single to a multifaceted approach. This way, producers can not only improve their weed management, but they can also be an effective part of the effort to prevent the further spread of herbicide-resistant weeds.